welcome you all to this another interesting chemistry session. So we're just going to continue from where we ended in the last series. So we'll do a quick recap on the ions. So we defined an ion as a fully charged particle, and we said an ion can be positively charged or can be negatively charged. Where we said a positively charged ion is known as a cation, and a negatively charged ion is known as an anion. So we said atoms lose or gain electrons in order for them to become stable. And by stability, we mean an atom should either achieve the duplet or the octet rule. So stability is attributed to achieving the duplet or the octet rule. So duplet, this is when you lose or gain electrons and you have two electrons in the outermost shell. So this is an example where lithium loses one electron and then it remains, so it loses the electron in the last shell and then it remains with two electrons in the outermost shell, in the outer shell. So when you have two electrons in the outer shell, you have achieved what we call the duplet rule. So these are the two rules that are supposed to be achieved, and then we'll say an atom is stable. The other one is the octet rule. So we are looking at an example right there where magnesium atom loses two electrons. So earlier on we said atoms lose according to their valence numbers and atoms gain according to their valence numbers. So non-metals lose metals lose according to their valence numbers. The non-metals gain according to their valence numbers. So we're looking at magnesium atom, which loses according to its valence number, and the valence number for magnesium is 2. So magnesium will lose those 2 electrons, and then its initial configuration is 2, 8, 2. So it loses according to its valence number, and its valence number is 2, meaning it's going to lose those 2, and it becomes magnesium ion, and its new configuration is 2, 8. So having 8 electrons in the last shell, this is the octet rule. So that is basically about the stability of atoms. So atoms in their natural state, they are unstable. They become stable by either losing or gaining electrons. We can continue. We looked at how to come up with an ionic formula. So people will be wondering, where do these ionic formulas come from? So when you see Ca2 plus or O2 negative, you might be wondering, where do these formulas come from? So I explained in the previous lesson that what is important is we have to know the valence numbers of these particular atoms. So we said group 1, the valence number is 1. So we have to know the valence numbers of these particular atoms according to their respective groups. And we know that there is a zigzag line somewhere here on the periodic table, and then it continues where we said we have nonmetals on the other side. So we have nonmetals to the right of the zigzag line, and we indicated negative in brackets, and then we metals to the left of the zigzag line, and then we indicated positive charge. So for you to come up with an ionic symbol like Ca2 plus or O2 minus, what is important is know the atomic symbol, know the valency number, then know the charge. So for metals, we always put a positive charge. For non-metals, we always put a negative charge. So if I'm writing for lithium ion, this is lithium, you ask yourself, what is the valency number? So the valency number is 1. Is it on the positive side? Is it on the negative side? So if it is on the positive side, if it is a metal, we attach a positive. Now we cannot say 1 positive. So 1 positive is the same as positive. If you're looking at those in group 2, for example, magnesium, so Mg, capital M, small g, the valence number is 2, then positive. So that is magnesium ion. If you come to the non-metal side, for example, nitrogen, it becomes N. The valence number is 3. It's on the negative side, so you put a negative charge. Oxygen, it becomes O. The valence number is 2. Then negative charge. So that is oxide ion. So that is how we come up with the formula of ionic symbols. Now, as of today, we are going to look at how to determine the PEN. How to determine the PEN. So the PEN is just proton numbers, electron numbers, and neutron numbers in an ion. We looked at how to determine the PEN in an atom, but now we want to look at how to determine the PEN in an ion. So ions, remember, we have a cation, which is a positively charged, and then we have an anion, which is a negatively charged. So cation, we are saying this is a positively charged ion, and in a positively charged ion, how do we come up with a positively charged ion? This comes from a metal atom which has lost electrons, and metals will lose electrons according to their valency number. So they do not just lose unnecessarily, so they lose according to their valency numbers. So we're going to look at the comparison here, that is for magnesium atom and magnesium ion. So I want us to see the difference between the PEN of the two. So in terms of proton numbers, when you look at magnesium atom, we have 12. But remember, we said in an atom, we should not forget this fact, the P is always equal to the E. So if your proton number is 12, your electron number will also be 12. How do we get the neutron number? So to get the neutron number, we get the mass number, which is 24. Then we subtract the proton number, which is 12, and we get 12. Now, in an ion, I will make this emphasis, the P is not equal to the E. The P is not equal to the E. Now, the proton number still remains 12. The neutron number still remains the same. You get the mass number, 24, you subtract the 12, you get the 12. But what is going to change is the electron number. So if we are looking at a positively charged ion, so a positively charged ion, we are saying this is an ion that has lost electrons. So there is always a loss. So whenever you see a positive means there is losing of electrons. So from the initial electron that an atom had, which was a 12, you're going to subtract the 2 electrons which has been lost, and the new number of electrons will be 10, which is the one that you are seeing here. So that is how we determine the proton, the electron number. So electron number, there is a loss, specifically if we are looking at a cation. So a cation, there is a loss of electrons. There is a loss of electrons. So they lose electrons according to their valency numbers. So that is for potassium, for magnesium atom and magnesium ion. That is what we are going to get. Let's look at another example. So what if we have, I mentioned potassium, it was on my mind. We have potassium 3919 and potassium ion. So potassium ion, we still have 39 as the mass, and we have 19 as the proton number, but we have a positive here. So when we look at the PEN of both, so in terms of the P and the N, they are not going to change. So this will be 19, this will be 19, and this will be 20. Sorry. So this will be 39 minus 19, and it's going to give you 20. So you have 20 here, you have 20 there, you have 19 there. But what is going to change is the number of electrons. So remember, in an atom we said the P is equal to the E. So this will be 19. But here in an ion, we will be guided by the charge. So what is the charge telling you? Or what is the valence number of this guy? So the valence number of this guy is 1. This simply means that from its initial state of electron, which was a 19, is going to lose 1, and therefore this becomes 18. So whenever you see a positive, I said always think of losing. Always think of losing. So this is what happens in a cation. In a cation, there is always a loss of electrons or an electron, depending on the valence number of a particular atom that you're discussing. Let's look at what happens in an anion. What happens in an anion? So we get back to the book and see what happens in an anion. So that is about a cation. We'll come back to the electronic structures first. I want to finish with the anions. So the anions, we said anions, there is a gain of electrons. In an anion, this is a negatively charged ion, of course, but there is a gain of electrons according to the valence number. Then there's just a note to remind you that anions, remember, they change their names. They use a suffix of DE or IDE. So what was called oxygen atom becomes oxide ion. What was called fluorine becomes fluoride ion. Now let's look at the comparison of fluorine atom and fluoride ion. So as you can see, the name is different. This is fluorine. When it becomes an ion, it's called fluoride. So fluoride is 19F negative, fluorine is 19F, there is no charge. So remember, an atom, always the P should be equal to the E, and that is why you have a 9, you have a 9. But in terms of neutrons, you get N, you subtract, mean, you get the mass number, you subtract the proton number, and you get 10. So the proton number and the neutron number will remain the same. These two will not change even when we go to the ion. This will still be 9 and this will still be 10. But when you look at the number of electrons, we are saying there is always a gain. So there is always a gain according to the valence number. So when you ask yourself what is the valence number of fluorine, so the valence number of fluorine is a 1. Therefore, from the initial 9 electrons, it gains 1 electron, 1 electron, 1 electron, and then it goes to 10. So whenever you see a negative, always think of a gain. So there is a gain which is happening. We can look at another example. So if we have nitrogen, so nitrogen is 14.7, and we have, so this is not nitrogen, but this is called nitrite, because it is an ion. So this is nitrite. So when we look at the PEN, of the two, in an atom, remember, the P is always equal to the E. But in an ion, the P is not equal to the E. It's either there is a gain or there is a loss. So this becomes 7. This becomes 7. The neutron number, remember, you get the mass number, you subtract the proton number, and you get 7. So make sure that you understand the language. Chemistry is about the language. When they say proton number, they say electron number, they say mass number, do you understand the language? So make sure that you understand the language, then it will be very easy for you to understand. So what about the P here? So the P still remains 7. What is going to change is the electron number. The N becomes 7, 14 minus 7. But for the electron number, we are saying, since it's a negative, we said the negative means there is a gain. So from the initial 7 electrons that it had, there is a gain of 3 electrons. Therefore, the new electrons becomes 10. So we'll find a lot of questions on these atomic and ionic structures. The principle is the same. Negative means gaining, positive means losing. So they can ask you all sorts of questions just to see and test if you are able to understand the meaning of a negative sign and the meaning of a positive sign. We can have a question like this one. Just give a rough sketch of my question. I give you this. I will say this is the P, this is the E, this is the N. Then we'll just look at maybe two or three elements. So we can have Na, which is sodium, 2311. We'll have Na, we'll look at the same, Na plus, 2311. So you can just pause the video and see if you're able to answer the PEN correctly for the two elements. Let me also put the EC. So the EC is the electronic configuration. When you look at the first one, when you just see that there is no charge, it means that you're looking at an atom. So an atom, the P is always equal to the E. So this will be 11. This will be 11. How do you get the neutron number? So 23 minus 11, we get 12. What is the electronic configuration? Electronic configuration, how do you arrange electrons in sodium? So 2, 8, 1. Then let's go to the second one. So you have an ion because there's a charge here. So the charge is a positive. So positive means it's losing. So the P will remain the same, but the E will change. This tells you that it has lost one electron. So this becomes 10. Neutron number still remains the same, 23 minus 11. Your configuration now changes because you have 10 electrons. So it means that it has lost that one electron in the last shell. So it becomes 2, 8. So that is how we determine the PEN when we are looking at atoms and ions. So basically that's what I had for you in this session. So in the next session, we'll look at how to draw the electronic structures of atoms and that of ions. Goodbye.